Hi, everyone. It's 2 minutes past. Well, let's get started now. My name is Srinivas. I'm Product Management Director in Cloud Security at Google.
And my name is Anotonio Lobato. I'm Director of Infrastructure at Whisper.
Today, what I will tell you about, and then Antonio will follow me, is tell you a little bit about what we call something called BeyondCorp at Google. In just, we turn the intranet inside out and put everything on the internet. And we actually believe it's more flexible and more safe. And I want to tell you some of the principles and concepts behind that, and then talk about tools we are building in Google Cloud Platform, which allows you to do something similar. And Antonio will take over after me.
Yeah, and I'm going to go ahead and I'll actually sort of share our journey moving from the sort of traditional model and actually starting using BeyondCorp. We use BeyondCorp right now in production. It's, yeah.
Thanks, Antonio. So just agenda, I'll start with the overview of the BeyondCorp concepts, and basically it leads to what concept we call ContextAware Secure Access. And as I go along, hopefully it'll become clear why we use this term. And so after the concepts, I will talk about how you could implement it on Google Cloud Platform, the tools that you have, and how they provide solution components. And then I'll step back to a bigger view. You will see the initial part of the conversation basically being about deploying your web applications safely onto the internet. But there's a much bigger story than that. And I'll step back to talk about how this is something which is very fundamental to the way the world is going today. And then I'll hand it over to Antonio to talk about his experience. So let's jump into it. Again, it's context-aware secure access is what we call this. And BeyondCorp was an internal term, how you can use it as an enterprise. So yesterday, or even today, often on-premise remote access is through VPNs, as we're all very familiar with. So an employee is virtually transported into the internal network, and the network has some level of controls, maybe able to access various applications, the ERP, CRM, and so on. And everything runs on the premise identity system, all of that's on-prem. Things started evolving, have been evolving. So you maybe wanted a contractor, and the contractor basically, you wanted them to access just a CRM system. It might very well be that you have a single sign-on, and by the very fact that you said, hey, we'll give the contractor VPN just like employees, they get a little more access than they should. Maybe the contractor is able to see something as the ERP system they should not, but this is the sort of status quo of how things work today often. There is not much methods of controls beyond the fact that you're either in or out of the system. Now let's look at evolution beyond that as a public cloud has happened. The applications themselves are moving out of the network perimeter of the premise onto the cloud. And so at some level, you have to ask, how can the VPN access work in this model? Sure, you can simulate the similar boundary and have a VPN and do it the same old way, a virtual everything. But the question was, can we do better? That's really the question we should be asking ourselves. And if you look at the evolution here, initially the identity system is still on-prem, but you can, things are evolving where wholesale, everything goes in the cloud. You may be using an IDaaS system, your ERP, CRM, everything runs on the cloud. In essence, the key thing to take away is everything is directly on the internet. So in this world, one could try and virtualize and build back the old model of it being a boundary. Can we leverage this and do better? That's the real BeyondCorp question. So to understand what we can do, it's worth looking at all the risks which go from the basic notion of information access. Information access, some human being has some intent in their head, and then they go and access some information which has some meaning to them. And they realize this through some various physical systems. So what are the various risks that physical systems can have? The first thing is when the user is, you have to ask at the point where the information is accessed, is it the real user? Is it the person who is really intended to see this? And we talked about phishing. That's a classic example where it may not be the real user who should be seeing this information. The next level is all access happens through a device. You have a mobile, you have a TV, you have computer, you essentially information access happens to a device, and the device itself can be compromised. So the question you ask is this device in a state which I trust to show this information, or is there some person who's riding on the side and looking at information, even though the user may be the right one? The next thing along the thing is the device accesses information in the cloud or over the network. So the network itself might be vulnerable. So can it be MITM'd? Can it be DOSed, where you basically you may not compromise information, but you deny access to the information to the user. And say all of these, let's say, were in good shape. The next thing is it okay for the user to see this application? This goes back to the contractor example I gave you. Can we do better than just say, hey, you're logged in, so you got to see everything, but without changing the existing applications, without changing your existing ERP system which you lifted to the cloud or CRM system? Can we introduce controls where only the contractor can only see the CRM and employees can see both, and finance can only finance can see finance applications? And finally, if you're looking at the entire path of access, the question itself is whether the application itself is vulnerable. There may be an XSS attack and things along those lines. So a holistic solution to access would address all of these things. It would improve or solve, so to speak, every one of these problems. So going once again at the risks, but now I'm going to use vocabulary which we are all familiar with. Is it the real user? Well, the user may be phished. It may not be the real user because somebody else got their password, somebody else got their OTP. Is it the device in a good state? Well, there might be malware in it. Do I know the device is malware or not? And it might be whatever ghost in the browser. It might be a browser extension problem. It might be malware, deeper keylogger, all of these things. And a man in the middle, basically, this can be range in sophistication, but basically the most basic question is it over TLS? And even in this world, there might still be rare situations where people find it too complex. But more importantly, is it TLS configured right? Is it using some old cipher which is easy to man in the middle and so forth? And then, of course, is the app policy access enforceable? Is there a mechanism that you have for that? And finally, the examples of issues with your application are SQL injection and things along those lines, or cross-site scripting. So what would you want in a solution where, again, you're deploying access, you're leveraging the fact that everything's on the internet, and you're deploying access safely? You would want to solve every one of these. Solve, of course, a very strong word. You never solve problems in software, but fundamentally improve, mitigate every one of these things. So you want phishing-resistant authentication. So you have a pretty sure it's the right user. You want device management and signal of the device management coming before you make an access decision. So you're pretty sure that device is fairly well managed, and you know it when you decide to allow the app user to see something. You are pretty confident that your TLS is well configured. You're pretty confident that you can take a massive DOS attack and you can still provide access. And finally, you have some tool which basically allows you to say things like contractor can only see CRM, but without changing, you don't want to go and say change everything, build software head-end so all your applications go, get your developers. A developer might have left the company, maybe 10 years old. It should just be a layer on. And of course, you should have tools which can do application security scans. This is not an all the other things I talked about are actually things you should have in real time, online, at the point of access. But pre-deployment, you should be able to at least scan your applications and look for problems with them. And so going from here, what I want to tell you is that in Google, on GCP, we actually are offering tools for all these components. And basically, it's you can do a substantial version 1.2 of this today with the tools that you have. And it's a deep investment area for us as a roadmap, because as I will tell you, when we step back to a larger view, it's much more than putting your Oracle system on the internet. There's a much bigger issue over here which we are addressing. So to go through these, basically, there's security key enforcement, which Christian talked about a little bit, and I'll again address briefly, but in the context of what I'm talking about here. Which is a feature that we provide in our IDP. So if you're using our identity system, we give you phishing resistance. If you're using devices, mobile devices, we provide mobile device management today, and we're actually also looking to extend that to desktops and get some signals also back into our IDP, so the IDP can be aware of the state of the device. And the Google Cloud Load Balancer is essentially a productization of how you experience Google today. So in Google, when you see anything in Google, it's served through something called the Google front end, which is the right way to call it is a planet scale web termination system, which can pretty much, it is under continuous attack all the time, and that thing, you can essentially put your application behind that very same thing. So you essentially can handle DOS at the level that Google can handle. And identity-aware proxy, we'll talk about it in a little bit more detail, and that's what is going to give you the access control saying Sam can see this, and Tom can see that, and Jane can see the other thing. And Cloud Security Scanner, again, are tools we provide in GCP, which, again, these are all individual tools. You can use them as you like. And the Cloud Security Scanner, you can use to scan your applications. So stepping back so far, in fact, let me continue. So let's think about what you really want in this ideal world. What would you like to say? What would you like to be able to declare as an administrator and say, I want this to be so, and the system takes care of it for you? And the point is, we are providing the tools where you can get to a world like this, as is described here. So the ideal access policy here gives an example. Let's say you're a French company, and you have basically some rule which says access should be from France. But basically, you have a finance application. So you can say something like this. I want this application to be accessed only by people in the finance group, only if the devices are well managed, only if they're in France by geo of the IP, only if I know they're using strong user authentication. And by the way, I'd better make sure that the TLS is well configured. And if I have a DOS attack, I can still release my financials on time. You want to be able to say this and say, system, make it so. And that's essentially what the tools we are building allows you to do. So each of these parts which I told you about is a different component of what you have in Google Cloud Platform. So the accessed only by finance employees is the identity-aware proxy. We'll talk about a little bit more detail. From well-managed devices, device management, working with the identity-aware proxy. I will, again, talk about that. The notion of the geo is just a roadmap item which is coming to consume more context in the identity-aware proxy. Strong authentication is a security key enforcement, which Christian talked about, but I'll again address briefly in this talk. And proper transport encryption is using our cloud load balancer that is putting an application behind our global front end, a Google front end GFE. And of course, hardened against application attacks is the cloud security scanner. So I want to jump now into one particular key component of this identity-aware proxy. And before I do that, maybe I should make one observation. The larger notion of what we're trying to do is, before, the notion of access controls is often in lower level notions like network, segmentation, VPN access, and so on. But the true thing you really want is access to information. So this financial report is an information item which only Joan should see. And this bug report is something which only the contractor group should see. And we're trying to uplift everything to the semantic application layer. So we're making all access happen at the application layer in terms of controls, and not worrying about low-level networking or lower-level concept. That's the basic. You can think there's another way of looking at this entire notion of context-aware access. And I should also say, in fact, I missed one point. I said context-aware secure access, right? And so the context here is, of course, it's the user, but it's also how sure you are it's the user. Is their device well managed? What geo are they coming from? This is the context. The access is not just, is it Joe? Is it Joe ++, which is the context, right? So going back to the identity-aware proxy, I showed you these various tools. We're going to focus on this proxy over here, the yellow thing over here. So this IAP is basically a proxy through which you publish your applications onto the internet. So here is an example. There's a company which has an ERP system, and it publishes it onto the internet as erp.acme.com. The identity-aware proxy does the TLS termination. It does the identity verification. It can also apply access controls. So the admin basically has to configure using the identity system, users and group access, so essentially things like the contractors can access the ERP or not, things along those lines. The IAP actually is built on top of what I call the L7 load balancer, but I should have said Google Cloud load balancer, the very same thing which I talked about in the Google Cloud load balancer on the left. It's a lower level, that's a classic load balancer, as you know, a TLS termination system, but you can think of the IAP as one layer above. So a TLS terminator, typically people call it L7 termination at the HTTPS layer. You can think of IAP as L8. It's even identity aware, one level beyond that. And so in this world, basically, the dev focuses on developing web apps, and the DevOps configuration, the Google does the security. So you basically do the notions of who can access what as just a configuration on the front-end proxy. And of course, TLS, DOS, all of that is just taken care of by the system. That's all just plumbing from the perspective of this. So we offload all of that from the developer's perspective. So the admin experience here is you configure IAP to do what you want. So for example, here you might configure that only the finance team can access the ERP system. And then what you would expect happens. So let's say Sarah in finance logs in. The IAP is, obviously, it is the one verifying the identity. It's aware of, now it's able to make a decision whether Sarah is allowed to see the ERP system or not. And Sarah gets access to the ERP system. And similarly, let's say Linda in engineering basically is logged in. Again, the login happens with a single sign-on through the Google Identity System. And now Linda tries to access the ERP system. Linda is not, by the rule, allowed to access it. So she basically would see a polite page saying, sorry, you're denied access to this resource. So a fairly simple concept, but it grows on to that same thing would also now, is it not just Linda, is Linda on a well-managed machine, is Linda coming from France? All of those things can be in the policy. So let me talk now about strong authentication, which is another component of the solution that we offer. So looking at this, basically, I talked about identity-aware proxy. I told you the cloud security scanner is an offline thing, so it's not part of the online solution. These left parts comprise an online solution. Identity-aware proxy builds on a cloud load balancer. Now let's look at, and there's Google device management feeds information which the identity-aware proxy uses to make decisions. Now that still hasn't addressed the question of, is it the real user? And here is where we have to have phishing resistance, and that's where security key comes in. Just to get some context, how many of you folks were in the immediately previous talk from this one, in this room? Okay, about half of you. So I will just cover a little bit of detail about this. The problem is phishing is the most common way by which accounts are compromised. It's basically the point is, why would you break in through the window, jump over the back door, and drill a hole under the house and so on if you can just ask me to give you the key? You can just walk in through the front door, right? So the simplest way to get into a system is to fool them into giving you the password and perhaps even the OTP. So it is the number one thing which is the leading way of compromise today. And the classic mechanism is I send you an email which looks legit, and it says, please reset your password or whatever, and you think you're going to Google or Facebook or whatever the web page is, but actually you're going to fake Facebook or fake Google, and boom, you lost your password, and the other guy's got your password. That's the basic mechanism. And essentially the key point is it is not something which you can ask users to solve. It's not because users are fools, it's because the infrastructure is inadequate. It's just like you don't ask people every time they drive a car saying, get into the car, check whether the brake hose is connected and so on. They just get in and drive, and if the brake hose gets disconnected, you get a red light and maybe the car auto stops. That's the way the infrastructure should work. Here it's actually expecting the users to do something which is fundamentally unnatural. So we have to fix that infrastructure in some fashion. So the security key is a phishing resistant second factor. So it's a dongle, and one I will talk about how you would use on a desktop. There's similar things in mobile also, but essentially you have the first, how do I say this? It's a login experience would be you just basically enter your login and password, and then you ask for a second factor. The security key is a second factor. You press a button on this thing, and it releases a cryptographic challenge. And essentially, it's phishing resistant. And how does the phishing resistance happen? Actually, it is the key thing for phishing is you got to ask the user, hey, is it really Google you're looking at? That job is offloaded by the security key because the security key, the browser tells it, hey, I'm looking at Google or fake Google or whatever it is which is on the page, feeds it a security key with the challenge which the login system provides. The security key signs across it with a private key, and then and it's relayed back to the server, and server is able to verify it. So in other words, the server can say two things. Is it with the public key of the particular user? Okay, I know it's John or Tom or whatever. Is it a challenge which I just gave? Oh, no, I know it's not a replayed, it's my fresh thing. And finally, did John or Tom really see Google, or did they see Facebook, or whatever they're supposed to see, or did they see a fake Facebook? And so essentially it makes it impossible for someone to relay the authentication. So it fundamentally increases the bar in terms of phishing. And I specifically, so we offer this in Google, both for consumers and enterprise. And for enterprise, you can have arguments about a hardware second factor sometimes being more inconvenient. But I think the point we want to make is to weigh it against the actual consequences today. And your CEO, his email getting phished is far more of a consequence than your CEO carrying a security key. But the security key mechanism and the form factors make it easier. So for example, in this particular computer over here, I use security key, but my security key looks like this. It's a tiny thing. It lives continuously in my computer. And so it's as if my computer itself became my second factor. So the typical question is, what if I forget it? What if I lose it? Now I don't ever lose it because part of my computer. And by the way, if I have two computers, I can have two security keys for the same account. If I have three different, if I'm using Google, Facebook, Dropbox, and let's say GitHub, I can use one security key across all four of them if they support it. And by the way, those 4 examples of websites do support this protocol today. So so it's convenient enough right now, and it solves a very deep problem. And it's like a smart card designed for the web. If you use smart cards, you stick it in the crypto. The smart card knows who you are, and you're signed on, single sign-on without anything further, maybe the smart card PIN. This is basically redesigned for the web where it's anonymous. It doesn't know who you are. And basically, it's self-use, so you re-register it in the device. And so various things. It has inter-domain privacy, so if you actually use it for both Facebook and Google, there's no way for Facebook to know whether you have a Google account, no way for Google to know if you have a Facebook account on the device. It's got a simple usage lifecycle, self-registration loss. If you lose it, you can have multiple on an account, and so on. And the nicest thing is if you drop it on the street and someone picks it up and says, wow, I'm going to ask what all accounts it has, again, it's worth a discussion later, but it literally does not know. You cannot ask it, hey, what accounts do you have? Because there's nothing it can answer. It only has a master key of its own. So it's at least the takeaway which you should have is about a security key section, coming back to this thing. Firstly, I'd point out the various parts, you can mix and match them as you like. But you can even use security key independent of anything else that you want for just a Google login, or it's an open protocol. If you say, hey, no, Google is not the right one for me, choose your favorite IDP. Some of them already implement security key as a feature because it's an open standard and multiple IDPs can use security key. Having said this, all of the discussion was very much about I've positioned this so far as I have a web application, it is my bug system, it's my finance system, put it on the web, no more VPN. In fact, that's a small view of what we're really doing. The big view really is, and it's not what we're really doing, the big view is what's really happening. What's really happening is your very infrastructure, which used to be your machines and so on, are all on the internet, and they're all virtualized APIs. So if you look at the picture on the right, before on the top it said CRM, and the bottom it said VM. I've gone one layer below now. The top layer is a VM, below is a compute API, which says let a VM be happening, let it run, let it shut down, stuff like that. Similarly, a storage might be like a disk. Create me a whatever physical disk, create me a SQL instance, whatever, re-index it. These are the kind of APIs that you have. These APIs access over the internet. And these APIs basically, again, you don't want to go back to VPN land because you're fundamentally, even your lower layer of your entire existence is now on the internet. And so you want the platform to pervasively give you this kind of security. You want a platform to say, I allow my compute APIs to only access by my developers, only on well-managed machines, only if they're coming from my corporate source IP because I'm doubly paranoid. And by the way, if it ever happens, maybe this is like a contractor who's doing some development, and so they can only come between 9 and 5. You just say that, and the platform honors it for you. And it's native, there are no proxies. It just happens natively in the platform. And this is where we are going with this thing. So, in other words, you can deploy applications through this thing, where you know our entity system can understand the context of your device and so on and give you an access, but it's natively embedded in how you access our cloud. Similarly, a third-party SaaS application, if you use access an IDP and accessing Salesforce, for example, you want to be able to say, hey, you can't see Salesforce unless you're from France, 9 to 5, all the kind of stuff. You should be able to do that, and that's what our roadmap is enabling, and this is coming in parts. So all the stuff I told you right now, as I told you, there's a version 1.2 you can use today. But the larger point I want to make is it's part of a deep roadmap. And the largest thing you want to take away is everything's on the internet. Everything is an API. And it no longer is okay. There's no hiding behind VPNs. It just doesn't work anymore. So every access, which is semantic access, has to be protected by a holistic context beyond just who the user is. And we are enabling that as a fundamental part of the infrastructure. And of course, deploying applications is just one sort of layer in that cake. And having said that, I will hand over to Antonio.
All right. Hey, hi everyone. A very loud, boisterous voice. So, my name is Antonio. I am the Director of Infrastructure at Whisper. We are a media company. So you might have seen our content somewhere on the web. We're big distribution network. So we were founded in 2012. And one of our core tenets, we started off as like an anonymous social network. And we've kind of grown from there as a media company, media distribution. So every month we sort of have this cross-platform reach of about 250 million people. And there's about 17 billion pieces of content that are consumed from our network every month. And this is over about 187 countries, give or take. It's pretty much almost everywhere in the world at this point. So, and one of our sort of key missions is to be able to deliver that sort of content to people, these anonymous thoughts and these feelings that people have, things that they don't want to put on Facebook or put on Twitter, but they want to talk to someone about, and sort of bring that out to people so people have a good context of what people are actually feeling. So this has its challenges. So to give you a little bit of insight, we sort of moved into Google Cloud from another sort of big box cloud infrastructure provider August of last year, and Google sort of it was kind of funny. Google sort of tricked us into using Google Cloud. We didn't. We were just like, hey, we want to use some data science stuff. Like, oh, did you look at Google Cloud? Like, it's pretty cool. So we ended up switching over, and I think it was probably in the almost 2 decades that I've been doing this, it's probably been the best decision that I've ever made in this career. So traditionally, we've had this sort of VPN, this open VPN, TunnelBlick if you're on a Mac, and all this really, really nasty setup to get into our infrastructure and do work internally. And it's incredible. Just this morning, 4 CVEs were announced for OpenVPN, including man-in-the-middle attack, stack smashing, overflow, all these crazy things just this morning. So kind of justifies the decision here. So we were taking a look at how we wanted to do this. So the VPN was very buggy. We had a lot of like access control problems. We had to narrow things down and do all this manual crafting. It was a huge pain. So that was kind of like our kind of key thing, and we're sort of also wanting to open up some of our tools to our contractors. We have a lot of external contractors that reach our systems, and doing that with the VPN was just very, very tough. Our headquarters is this giant metal warehousey looking building, and the Wi-Fi jumps all over the place, and the VPN's constantly disconnecting. Huge pain for just logistically internally as well. So we took a look at BeyondCorp after Google Cloud Next in March, and we're like, okay, let's take a look at this. And it was insane. it was genuinely the most, I think the most amazing sort of like googly product that I've used coming out of there. And we took our very first sort of like networking dashboard, something like, we need to like view these beautiful graphs of our network and our layout and all of this stuff. And we sort of threw it behind BeyondCorp. The time that it took to do that was about 5 minutes of work, no joke. It was almost effortless. And that in itself, it just speaks volumes, right? And with that, we gained the whole load balancer, all of that key things. So now when people access this tool, this network map, they get the sort of Google login screen, just like you would if you were logging into your personal Gmail. And they sign in, and then it passes through. The really, really cool thing about that, and I think that the number one thing that is very important to denote here, when you hit the BeyondCorp IAP sort of platform, you're asked for authentication from Google before any code or anything is run, any request goes to your backend server, goes to your backend software. This is amazing. And the reason being is our other main backend tool, this administrative tool that we have to do stuff, was written, I think like 4 years ago in Ruby on Rails that hasn't been updated in like 3 years, and that we just kind of hide behind the VPN, right? Now we can open this up to the internet, and Lord, I know for a fact that you can root this thing, like there's definitely some bugs in that login screen on that Ruby on Rails app, but we don't have to worry about it, right? Because we trust our users in that sense that once you're authenticated with Google, you're in the system at that point, right? And then just integrating that whole IAP sort of setup has just worked out really, really well for us. So and then this is roughly what it looks like now, right? So if you guys know like more developer-y stuff, Jenkins, things like that, build systems, put it on the internet. We don't need a VPN anymore. Now that's all tied into IAP, and it just works. It really does just work. That being said, not everything is quite as sunshiny as it's made out to be. There are some things that while you technically can do them today, this is sort of my like, by the way, I'm not a shill, I'm not paid by like this is there's genuinely some real criticism here. And I think that one of the kind of key things that sort of we're really looking for is the ability to control like that URL access. So one person or one group of users has URLs that they can access a certain set of URLs, and then another group of users can access another set of URLs. You can do that today, but it is a huge pain in the rear. Like, it is massive pain in the rear. So, and you really just, you have to jump through these, and it's just a lot of work. So, and I do know that Google's actually working on this. I think that there's a timeline to actually get this out there. So you'll eventually be able to do the more narrow, like finance can access this, engineering can access this. So that is coming. We're very eagerly awaiting that to come out. So the other one is session link. So if you log in, you're using the app, and if you're idle for about an hour, it kicks you off regardless, and that's not configurable right now. So that's another, actually, there's two use cases. We want to go to the extreme low end. We want like a 2-minute idle timeout on one, and then the other one we want like a 30-day idle timeout, right? So we want to be able to configure that. That's not there yet. That also is coming. So that's something that we're very much looking forward to. And then we also want to sort of finer grain control as to like what application needs, second factor. This set of users using these applications require a UTF key or require some sort of key. And that's, very high level super administrators should require, UTF key, whereas like somebody who's like in read-only mode, whatever, we're not going to make them go through the pain of like doing the thing when it's something that's not critical, right? Yeah, so overall, the entire thing, if you're not looking, or at least sort of understanding how BeyondCorp actually works, and it's kind of a goofy name, but it's IAP as it is. It's really worth it. Not just in the sense of security, not just in the sense of the calming, but in the sense that you can sort of just set it and you don't need to think about it. Now you can focus on running your business and making money and growing your company, and not having to worry about like, secure. I need like 3 PhDs working in-house. Like all that kind of goes out the window, right? So highly, highly recommend it. It's been an amazing transformation for us. Yeah, that's it.
Thanks. Any questions? Can I hand you the mic?
Thank you. A question on your identity store. So do you still keep your identity store on-premise and use federation, or do you just sync to GCP, or did you move identity store to GCP as well?
So we've always been on G Suite. That has never changed. So from day one, we've always been using Gmail. However, we did have an on-premises sort of LDAP, on-premise, but it was in the cloud, right? LDAP server that we would use, and we ditched it. We're getting rid of it everywhere, and we're just tying into Google Auth with BeyondCorp with IAP.
Yeah, it's worth saying that it supports both modes of operation, right? If you want to federate to it, to federate to Google and then connect in IAP, that's something that we support.
Okay, just a quick question about other tools that you may be using, but other than the browser. So I assume in your development environment and other environments, you must have other tools that you need to use and access the services running in the cloud. So for those tools, how are you going to do strong authentication?
Yeah, so that's actually a really great question, and I'll repeat that. So essentially for the things that aren't necessarily web, that aren't necessarily Jenkins, like SSH is a great example, right? Or anything else that needs sort of like this tooling to access, how would you handle that in the principle of what is BeyondCorp? And the really, really cool thing about that is I'll give you a really, really great example. So part of our move over into Google Cloud has been using, if you've guys heard of the technology called Kubernetes, containering, like using containers and all of this stuff. And we actually use Google's sort of built-in container engine in their cloud. All of their APIs for all of that, the first time I used it, I was like, oh my God, this is open to the internet. This is terrifying. And then you realize, well, so is my Google Administrative Console, you know, so is Amazon's AWS console. That's all open on the internet right there. So we built all of our command line. We have our developers who do all these command line toolings and making builds and doing deploys and all of this stuff, and it hits Google's APIs. Those APIs are protected by the same principles of BeyondCorp, right? It just happens to be fully managed by Google, but those people, they still need to go in, do their authentication, get the token. Like that's still part of the process for developers, even when they're using non-web browser-y type stuff.
I would like to emphasize that, you know, if you have SSH access right now on Google Cloud Platform, you first log into Google through the administrating console, and then you get an application called G-Cloud. The key point is you are logging in with whatever policy you set for your Google account. So if you set your Google account to say you have to have non-phishable or whatever phishing resistant authentication, that will kick in too. And going also one other point and make a little bit more forward-looking is that, as I said, the basic notion is that we want to provide application access, application layer access with access controls. And if you think of SSH as one kind of application which is different from HTTPS, we're trying to bring similar notions of even access controls, basically saying that only these people can access these machines and so on as a front-end proxy. That's something which we are actively considering. And that's a kind of slippery slope. At some level, you can say, I want, you know, my old 3270, which runs on port 26, I want something running on UDP, at which point you have to fall back to essentially proxying TCP over the proxy, which is not where you want to go. You keep the value as long as you have few well-defined application protocols and you apply access controls at the user level to those things. So it'll be SSH, RDP, web, things like that.
And you know, one thing I'll add to that, one thing that we found when we were deploying this at Google was by essentially tunneling like we had a bunch of our own random applications running on random ports and whatnot. When we deployed this internally, we bit the bullet and tunneled all of that stuff over a standard set of protocols, you know, things like HTTP or our gRPC protocol, and that tunneling enabled us to put strong identity on all of those other protocols. And so that act of like moving up a layer from TCP to some sort of identity-aware transport protocol enabled us to really up our security across all of these command line apps. So that's something that, like, you know, as Sam said, the platform is growing those features, but that sort of kind of thinking is something that at least we found a lot of value in when we deployed this.
In your architecture, you talked about IAP, right? Some more of a policy manager. Is this the centralized policy managers where Google controls and stored in centralized manner, or it's decentralized to the application specific?
Well, I don't know exactly how to interpret your question, but I would say that it's a service available to Google Cloud Platform, so it's not software that you run. So it's just so it's you as administrator configure whatever your policies are which you want on the service, just like you might configure whatever policy you want on a load balancer or something else. And you can do that either with a UI or through an API.
No, what I meant, my question was, is it centrally stored someplace? Is Google, you know, all the, you have thousands and thousands of application. Every application has their specific IPN rules, right, or IAP rules.
Mm-hmm.
Are they stored centrally, or it's specific to the particular application? It's decentralized.
Well, I don't know. I'm not quite sure the storage question. The point is, you do write rules per application, if you so choose. So you basically say, what do I want for the ERP system? What do I want to see as a system? Obviously, you can have defaults. Basically, here is my default thing, and I want these to be in a specific category and so on. So that's essentially speaks to the flexibility of the access control language. But is that what's answering your question? You're talking about physically where the bits are stored at the configuration.
Yeah. Second.
Well, it's in our cloud. I would say that as a first answer.
Can I actually, so one of the things, so to answer sort of on that, it's important to note that BeyondCorp IAP, all of that stuff, is not software that you deploy anywhere. It's not anything that you have to sort of configure. It's just part of the load balancing offering as it is. And your application that you write doesn't even need to be aware of it. Your application doesn't need to have a context or knowledge that it's running behind IAP. If you have some bit of software, for example, a dashboard, that it doesn't matter, you don't care like you have a username in the dashboard or all that stuff, you just want to protect it, you can do that. And you just throw it behind it, IAP intercepts it, and then when you're authenticated, it just sends the traffic along. And then you don't have to have some sort of notion of like, this application needs to be aware of IAP and know who the user is and all that stuff. But if you want to do that, IAP sends down several headers with the request. So it sends down like, this is the user, this is who they're authenticated, this is their email address, here's a token for it. So your application can parse all of that information and then personalize it and say like, oh, welcome Antonio, here's your mail, whatever, you know? So that's, I think that's kind of like the answer that you were looking for. Okay.
Appreciate it.
Yeah, in fact, that's a very critical point worth emphasizing. That is, the value proposition really is your application stays unchanged and doesn't really have to change. So the dashboard is a classic example. In an old world, it would be like you put a F5 load balancer, and the F5 load balancer also could be aware of the user and apply access controls. This is something as a cloud service.
Does it support a single logout, where if I log out from Google, once I log in, it would log me out from all the applications that I have a session with? And also, does it support a global session management or a distributed session management?
Yeah, I guess basically the IAP acts as a essentially relying party to our primary identity, and it's rechecking the credential every so often. So you do get logged out, and we also, you will get, this also speaks to the point of session lengths, which will come, which is something we're actively working on, so you can have different session lengths for different applications. So it's exactly how you would expect a federated application to interact with IDP. That's essentially what's happening. Yeah, wait, can you add a dash?
Yeah.
If you sign out of the IDP, then it signs you out of all the applications.
Yeah, that's given, yeah.
Hi, can you explain to me how IAP is different to Gatsby, a cloud access security broker? Or?
Yeah, see there's a notion of, let me take a particular case. Gatsby at the highest level is about visibility and control over multiple web application. So the way I understand Gatsby is before, you had all the infrastructure, you had Siebel software, you had whatever Microsoft Exchange, you know who was accessing what. You fired someone instantly, you could turn them off and look at all their logs. Now suddenly you went to a world where it's Salesforce and it's Office 365 and it's Google Docs, and you feel you're losing control because everyone's having direct interactions. What you want is a common place where you can say who's doing what, and I turn them off, and things like that. That's what a Gatsby does. So a Gatsby, basically, a first generation Gatsby, I think we're moving away from it, also had this reverse proxy notion. And the reverse proxy notion is actually a little bastardized. They would pretend to be google.com with basically a wrong certificate and therefore intermediate. So that's a reverse proxy. But that is, at a superficial level, that's exactly what IAP looks like. But IAP is not pretending to be anything. It is your front end. So it is a classic load balancing front end with identity awareness. So it's serving a different purpose. The purpose of the IAP is to project your application securely to anywhere on the planet. The purpose of the Gatsby is to give you control over the application. Gatsby fundamentally has value, especially when it's a multi-cloud kind of context. But the right way for Gatsby to work, which is where they're all trending, which is where the cloud providers are also going, is to provide the Gatsby a lot of APIs, saying, what do you really want to know? Do you want to track how many times this guy is logging into Gmail? I'll give an API for that. So you can provide a report to your administrator. So that is the right way for Gatsby, and considering they're adding such a fundamentally useful function. Basically, I think the web or the cloud is sort of hewing towards that. The Salesforces and the Googles and the SuccessFactors and the Microsofts of the world, all of them are providing what the customers want aggregated by a Gatsby.
Could you go into a little bit more detail on the DDoS protection that you mentioned? I assume that part of it is layer 3, 4 protections that other cloud vendors are providing as well, but specifically up at layer 7, both on the flow where your authenticated endpoints, I assume we're not going to see that traffic, but then for unauthenticated endpoints, or for cases where the IDP is not Google, could you just go into a little bit more detail on what you'd be providing there?
In the case where the IDP is not Google, your primary defenses will come below layer 7. So it would be like SYN floods, some massive traffic attacks, and so on. Basically, you're coming to a Google front end, which is looking at lower layer L3 and so on. You're going to get automatic protections for those. Where you do get L7 protection is if your primary login is Google, and basically the repeated login page fetches and so on and so forth. Essentially we're an SDN, which is aware at multiple layers of the attack on the system. So there is a front end which is dropping packets if it's a packet level attack, but if you're fetching abnormal amounts of, like, say, repeatedly fetching the login page or something, it's able to throttle that at the GFE service level. But coming to when you're serving through us to your end user, certainly if you have a network level attack, because you're serving through GFE, you have all kinds of controls. But if that user now is authenticated and now is repeatedly fetching a whole bunch of information, that's not what we do today. But you can imagine a future where something like the application proxy also becomes intelligent about content level attacks in a system. So at one level it is, how come this guy is downloading 100 megabytes of data? Another level is, how come this guy is looking at 100 reports when he usually looks at one a month, And we can see things like those, not necessarily which Google has to build, which Google might consider building, but you can imagine an opportunity for applications which are running in a daisy chain in front of your application. So you publish your application, there's an intermediate proxy, and that is behind our front-end proxy, and that can add intelligence about watching traffic and so on.
Gotcha. So it's fair to say then that you basically have the layer 3, 4 protection plus, if we're using Google as an IDP, then the protection's there, but that's basically it at this point.
Yeah.
Okay.
Is there any capabilities for IAP to accept tokens issued by, say, a different OAuth server? Say I've stood up an API and an OAuth server that's already servicing it. If I just want to put the API behind IAP, can it accept tokens that have been issued externally?
We should talk more. It's right now, IAP in discussion version 1.0, the only IDP which it can rely on is Google. But an obvious place for us to go is to rely on other IDPs. When you rely on Google as IDP, it's the one thing is if you want to apply access controls on the application side, you need the federation message to somehow tell you things like groups and so on and so forth, and that's where it has to go. So, but having said that, if you want to publish an API on GCP and you want it to have reliance on some other IDP tokens, and even more, you want to have accounting how many times API is called, we have a different solution to that. It's called endpoints, but we can talk to you more about that if you like.
Do these applications have to be in the same subdomain?
I'm sorry?
Do the applications have to be in the same subdomain? All these applications?
No,
They can be in
they can
any
be
domain.
anything that you like.
Thank you, guys.
Thank you.
Thank you.